Hello everybody. In this video we'll be covering one of the sections in chapter 7 of our textbook entitled Chemical Reactions. In this video we'll be talking about what evidence to look for that gives us an indication that a chemical reaction is happening. So far in everything that we've been learning, we still haven't covered any chemical reactions, really. We've never really turned anything into anything else. One of the first things we want to do is talk about what a chemical reaction is. So reactions involve chemical changes in matter that result in new substances. Reactions can involve the rearrangement and exchange of atoms to produce new molecules. So our atoms are going to rearrange to create new molecules. The elements, they never get transmuted during a reaction. What that means is that we're not going to turn the elements that make up the atoms that are in our molecules into different kinds of elements. At the beginning, we're going to have the same number of atoms of the same type as we did in the end. Another way of thinking about transmutation would be like the old school, like turning lead into gold and stuff. And that just doesn't happen under normal circumstances. The only way to actually get a reaction like that is to have like nuclear fission or nuclear fusion. And so that's a little bit outside of the scope of the type of reactions we're going to be talking about. Atoms of different elements can combine to make new compounds. So that's basically the rearrangement idea there. And sometimes molecules can combine to make even bigger molecules. Sometimes the exact opposite can happen. Molecules can decompose into smaller molecules or even atoms, and atoms can be exchanged between molecules or transferred to another molecule. And at times, we're going to change the amount of electrons that the atoms have. So they wind up gaining or losing electrons. This is going to turn them into ions like we've been talking about. Or it winds up changing the charge on the ions that are already there. So they could already be ions, but they could have a different charge at the end of the reaction. So what are some evidence of chemical reactions? First thing we want to do is we want to look for evidence of a new substance. So did we make something new that wasn't there before? And then we can start to look for permanent visual clues. So if a new substance is formed, there's going to be a change that's going to be permanent. It's not going to be a temporary thing that stops and it goes back to the way it used to be. Like, for instance, if you heated up a piece of metal, it would turn red hot, and then when you stopped heating it, it would just go back to looking like it did before. We're talking about something that's changed permanently about the material. So we could have a color change. We could have a precipitate forming, and that's when a solid starts to form when we mix together usually two liquids. So we see a phase change. The new material is solid and it's not soluble, and we'll talk about what that means, in the liquid. Sometimes gas bubbles start to form. That's us evidence that we're producing a gas in our reaction. Sometimes there are large energy changes. This is a picture of a strip of magnesium that's on fire. So a chemical reaction is occurring, specifically combustion there. But it could just as easily get very cold. And then something a little bit more exotic, you can see like the emission of light. This is a glow stick that's emitting light. The reaction that happens in fireflies is also a chemical reaction. This type of reaction is known as what is known as chemiluminescence. And then there are some other subtle clues. You could have a new odor that forms. There could be a sound that you might hear, like a whooshing sound from a tube that would indicate that gas is being formed. Or you could see it change state and remain in that new state. Think of like Jello, right? You mix it together, it's a liquid, you heat it up, a chemical reaction happens that causes the little jello molecules to start connecting to each other, and then in the end it remains in that gelatinous form. So it is important to understand that when we say these things, we're just talking about evidence, and that's not proof that a chemical reaction happened. Okay? In order to be absolutely sure that a chemical reaction has taken place, you need to go down to the molecular level and analyze the structures of the molecules at the beginning and the ending. So we need to really analyze these. So we can have evidence that maybe a chemical reaction is happening, but we really need proof. And a good example here is one that we've already seen. So we said that gas bubbles coming out of the mixture would indicate a chemical reaction. But we have seen that boiling is just a physical change. So it's not a chemical change. A chemical reaction isn't happening in that case. And one of the good indicators of that is when I take the heat away, the water stops boiling and it goes back to its original state. And even the water that escaped, in this case, would eventually condense and turn back to the original state that it was in. So let's go through these guys and see if we can decide whether each of the following involve a chemical reaction. The first one is photosynthesis. This is the process where plants take light and carbon dioxide and turn it into sugar. And yes, that is a chemical reaction because we started off with CO2 and H2O, and those got combined to produce a new kind of molecule, a carbohydrate, some kind of sugar. Heating sugar until it turns black. Is that a chemical reaction? Yes, that's the sign that the sugar is decomposing. The black material that's left over is carbon that's present in the carbohydrates in the sugar. Heating ice until it turns to a liquid. No, that's not a chemical reaction. The ice is water and the liquid water is water. And that is a phase change, and we know that those are only physical changes. The digestion of food, is that a chemical change? It sure is. The food gets decomposed, and it's when it combines with your stomach acid, and it ultimately produces something that does not at all resemble the original food. Dissolving sugar in water, is that a chemical change? It's not. You still just have sugar inside of water at that point, and you could even reclaim it. If you allowed the water to evaporate away, you would be left with the same kind of solid sugar you initially had. So this dissolving is not a chemical change. Burning of alcohol in a flambe dessert. Yes, that's a chemical change because we're burning. Anytime that we're burning, that's a combustion reaction. We're mixing oxygen with it, and the product of that is going to be CO2 and water.